G'day viewers, been doing a bit of photon analysis, so we'll go through my mathematical analysis of a photon, and I'll make some what do you call it, proclamations. Yeah. Okay, I'll state emphatically, a photon is neither a wave or a particle. It is a travelling quanta of electromagnetic energy. So we're looking at a photon is a lossless packet of energy that has both electric and magnetic values that change in relationship to frequency. And obviously frequency is related to time. In all the videos from now on, I'll be using standard international constants. I won't be making up any big fancy words. I'll be using plain English to convey my analysis to you people. It's for your review and criticism, whatever. So we'll look at how the magnetic field rotates along the x-axis, how the electric field changes in volume. That's right, it's three-dimensional. It changes in volume along the y and z axis. As it's moving along the z axis, it changes in magnitude, difference between positive and negative, but it changes in volume as well. This is where you've got to realise you're pumping energy into a field, and then that energy will collapse back down to zero, and then it'll reverse into the negative, and then it'll collapse back down to zero as it's moving along the z-axis. Now we're talking about free space. The velocity of light along the z-axis is how fast the photon will travel, and I've used a few mathematical graphs so that I can give you a view. I've said here the pressure, the voltage changes in sinusoidal value related to the number of degrees of magnetic rotation. Everyone knows that. You do that and you just come up with a sine wave. But what that is doing is giving you a voltage reference per degrees of photon's movement relative to its wavelength. You'll understand as soon as I show you some pictures. Actually, I might duck to one of the pictures now. Right, this picture here, this is three-dimensional, but we're only looking at a two-dimensional view. This is the photon's electrical pressure over its wavelength. Now, this is not what a photon looks like, but this picture produces the actual image of the photon. As you see from the zero line from left to right, that's in number of degrees, and as you see at about 90 degrees we've gone up to a maximum of 1, and also the opposite to that is the maximum of minimum 1. So in this particular photon we've got a pressure of 2. Not a pressure of 1, we have a pressure of 2. But the electric value is only 1. I'm just trying to show you something. It's like the three-dimensional volume of this spindle, and that's what a photon actually ends up turning out. It looks like a double oblate spindle. Yeah, crazy I know, but bear with me. I'll show you another picture. Just remember, this is looking at the y and z axis plane, as I've mentioned up here. It's a two-dimensional view, but it's a slice of the photon. If you were to look at the any other planes, like maybe the x z axis plane, it would look the same. This is a three-dimensional, like a couple of lemons, end to end. And I've got to thank you guys for sort of provoking me into this analysis mode. I wouldn't have done it otherwise. But we're going to have a look at the magnetic rotation. Right. How freaky is that? What we're looking at here is, I'll just uncover it there, the south magnetic pole is at 0 degrees and the north magnetic pole is at 180 degrees. Alright, so what do you reckon? That's how they are. Magnets oppose, they've got opposing fields 180 degrees apart. Yeah. But this thing rotates. As we're going along that z-axis line, that which is the, what do I call it? I've got some notes here. That direction of force, that I've got too many notes. But anyway, the z-axis is the direction of motion, or your force axis, because the photon is forced to travel along the z-axis. And why is it doing that? It's that simple right-hand rule. You've got force going along, the force is travelling, the electric force is travelling parallel to the y-axis. The magnetic force is parallel to the x-axis, and the direction of travel is the z-axis. So, just looking at some more of my notes. Yeah, I called the z-axis the motion force vector, the direction of travel. I called the x-axis the magnetic axis, and the y-axis the vertical electrical polarization axis. So if this, see this, this math that I've done here is applicable to any frequency photon. Doesn't matter if it's gamma rays, light rays, or 50 hertz power. This is applicable to the whole range. So what we're doing is we're building up a 3D picture, and I've got a pretty good idea of what it is already. But that's very interesting that it drew that spiral out there, that you've got two arms that spiral through the full 360 degrees. And it would have been easier if I'd worked in gradients, yeah, where you got 400 degrees to a circle. Everything would have worked out real beautiful. It doesn't like this base 60 to work out sine waves. So anyway, we've done a bit of analysis, and what I've learned is that people doing their magnetic analysis and interacting photons with magnetic fields, you might be in for a bit of spin trouble there, and what you think you're seeing might not be what you're seeing. You might be seeing photon spin interaction, and where all the photons are lining up and they're offsetting by so many degrees. And yeah, a magnet to me is a static field. Unless you move it, a magnet is a static field. It's no secret gateway to 0 point energy. Talking about 0 point energy, why don't we go back there? Right, there's your 0 point energy right there at each node, at each 0 point. You've got 0 voltage, you've got 0 magnetism, i.e. 0 current, 0 voltage, 0 power. There's 0 power at the 0 point. All your powers in your positive cycle. This would say the first one, it's arbitrary. Look, you can say the first one's positive and the second one's negative. I graphed them out. That's a three-dimensional image there, and you've got this crazy looking spiral, and you've got to interpose the two of those together. I don't want to make up big words because we end up with a crazy looking thing, and I'm pretty happy with my analysis so far. It's all mathematically correct. Just remember, I'm saying a photon is a quanta of energy. It is not a wave. It is not a particle. It's not a particle because it doesn't have mass. And because it doesn't have mass means it can travel across the universe at the speed of light. If it had any mass, you wouldn't be able to get it to the speed of light. These are just interwoven rules, and it says that you can do this and you can't do this. So right, I agree that the photon travels at the speed of light. I agree that it's a quanta of energy. I agree that it's a rotating magnetic field. It has a wave function. It is not a wave, and it is not a particle. It has a wave function, that's all. And the wave function, as I see it, is a little bit different to probably how a lot of people see it. Now, I've gone through this work. I've done the analysis. I've done a lot of thought about it. And I reckon in a few days I could have a full 3D model built of a photon. And it's not going to be what you think. It's probably going to be, well, I think it's going to be like two balls or two lemons like this, but rotate that picture there 90 degrees on its side, flatten out the most outer end pieces, and then make them travel as two balls or two, as basically an infinity symbol, where instead of travelling from left to right, if that was a photon, it would be travelling up and down the page. Well, it travels in one direction, it would be travelling up the page. So that's my views. Quite welcome for criticism. Not interested in, well, say whatever you want, I don't care really. This is my bit. I'm Rob Ritchie. Thanks for watching my video.